So today's lesson, we are going to go over an introduction into limits. So instead of just kind of easing into things and saying, oh, what is a function? We're going to just jump right into limits and start learning some new math. So we have example 1 for the given function f of x equals 0.75x if x does not equal 4, and 6 if x equals 4. Describe where the graph is exactly at x equals 4. Well, first let's talk about this piecewise function a little bit. We have the statement that it's 0.75x if x does not equal 4. So that means everywhere that it's not 4, we have this function. And you can see that here. And then it says if x is 4, our function is up at 6. So that's this little bubble right here. So part A says describe where the graph is exactly at 4. So when x is equal to 4, what is the y value?
6.
Yeah. Then y is equal to 6. And we can do this graphically. So if we go to x is equal to 4, and we look up, the only place that we have an actual dot is up here at 6. And so what that's actually saying is f evaluated at 4 is equal to 6. So kind of bringing back those piecewise function days. Ugh. Okay, any questions for me? Part B says describe where the graph is close to x is 4. So not at x equals 4, but when we're getting really, really, really close to 4, what is the graph doing? So if we look at it as far as, let's go from the left-hand side. If I'm approaching 4 on the x values, my y values are approaching a particular number. What are we approaching? 3. So when the x values get close to x equals 4 on the left side, the y values get close to y equals 3. Does everybody agree with that? Okay. Now let's look at that from a different angle. What about if we're going from the right-hand side? So we go from the right of 4 and we're approaching 4. What are my y values approaching? So if we're coming in from the other angle, what are the y values going closer and closer to? 3, yeah. So when the x values get close to x equals 4 on the right side, the y values get close 2y equals 3. So we can make a statement that as the x values get closer and closer to 4, our y values get closer and closer to 3. It might not ever actually reach there, but it's getting closer to there. And I always think about this as the I'm not touching you game. Let me come around here. So like, if I want to know what y value this podium's at, I'm going to approach it and I'm going to get closer and I'm going to get closer and closer and closer and closer and closer and never actually touch it. And so we can see as we're approaching something, what's happening, but it might change when we get there. So a statement that we can also make is, since they're on both sides, we're approaching that same number. When the x values get closer to 4, the y values get closer to 3. And you know, mathematics, we have to always give things a name and call them something weird. Well, this I'm not touching you game, or I'm approaching something but never actually going to reach it game is called a limit. And so what we can say is that the limit of our function f of x as x gets closer to 4 is 3. I don't know about you guys, but writing that whole sentence out is kind of a pain. And that's a lot of writing of words. So in mathematics, we give things symbols and letters, and we don't always write whole sentences. We rather use symbols. So to rewrite this particular statement in terms of mathematics, we say the limit. So we write lim as x approaches 4. And so underneath that LIM, we write x is going to 4. And it's of our function. So of f of x and what we're saying is that is equal to 3. So coming in from both sides, that limit is getting closer and closer and closer to that number, and that number is 3. All right. So that's kind of doing this graphically. If I wanted to do this a more algebraic approach, what we would want to do is make what's called a t-chart and look at what this function is doing closer and closer to 3. So to make so this was all graphically. So using the graph. If I wanted to use algebra, what we would do is make a t-chart. So an x and y t-chart. And we'd look at the left-hand side again. And we'd look at maybe, so we want to get closer and closer to 4. So we might look at 3. 3.5, 3.9, 3.99, and maybe even 3.999, but never 4. Because when we're talking about a limit, we don't care what's happening at 4, just what's happening when we get closer to it. And so when we plug these numbers in, and you would plug them into the original equation, so we would plug in 3 into 0.75 times 3. And when we do that, we get 2.25. If we plug in 3.5 into that equation, we get 2.63. If we plug in 3.9, we get 2.93. Plug in 3.99, we get 2.99. So what are those y values getting closer to? They're still getting closer to 3, right? They never are 3, but they're getting closer. So on top, and I wrote too big, we're getting closer to 4. And on the bottom, we're getting closer and closer to 3. And we call this from the left-hand side. So we're starting on the left of the number we're looking at. And then you can put 4 in there, but we know 4 is really 6 and we don't really care about it. That 4, when we're talking about a limit, doesn't really mean anything to us. It's only as we're getting closer. All right. And then if we want to look at this coming in from the right-hand side, we might look at 4.1. So a number that's bigger than 4. Maybe something a little bit closer to 4, like 4.01. And then maybe a number even closer to 4, like 4.001. If I still, after I plugged in those numbers, if I still wasn't sure, I can get even a little bit closer, like 4.00001. And then the next one, 4.00001. So you just keep tacking zeros in there. From the left, you keep tacking on 9s. So if we plug on 4.1, we get 3.08. 4.01, we get 3.01. And 4.001, we get 3.001. And so again, we're coming in from the right-hand side of the number. So we're getting closer and closer to 4. Our y values are getting closer and closer to 3. So that's how we would do that algebraically. If I didn't give you a picture, you can just take each of these numbers and plug them into this equation. Okay, any questions? You guys are quiet. My DiffyQ class is like super loud and chatty. They've had me for 2 years. So, all right, if you guys have questions, feel free to ask. I am typically pretty nice. All right, so what I want you guys to do is go ahead and try example 2. questions? All right, so even if you're not done, so I told you guys last class, I really like group work. So now that you guys are done, what I want you to do is pair up or get in a group of 3, or feel free to talk to multiple people. But what I want you guys to do is talk to each other and explain how you did this problem. Maybe one person did it one way and the other person you pair up with did another way. Don't just compare answers and be like, yep, we both got this number, good to go. But actually explain how you did it. So try and explain it 2 different ways and actually talk to each other. So go ahead and do that. You can turn around, you can move around, you can yell at each other. That's cool too. Whichever works best way for you guys. You may have to turn it around. If you feel like staying in like your spot, feel free to, or if you want to move back, you're going to be moving a lot. That was the other thing I forgot to mention at the beginning of the class. I like people talking to each other.
Okay, so we're gonna keep doing this?
Yes. And feel free to talk in your normal voice. You don't have to whisper. You're the only ones in here. All right. So let's do this one together. F at 1. What'd you guys get? -2? Everybody agree? Yes, perfect. Okay, so yes, f at 1 is -2, and what that is saying is if x is equal to 1, then y is equal to -2. Just kind of putting that into words for people who like wordy things. Okay, so part B says find the limit as x approaches 1 of f of x. Before we go into all the word part of this, what do you guys get as this limit? 4? Everybody agree? Okay, perfect. So we got 4. And what we're saying is as x, as x is approaching 1, so as we're getting closer and closer to 1, my y values are getting closer and closer to 4. It doesn't matter what it is once we actually get there, don't care. But as it's getting closer, this is what's going on. All right, so let's look at this 2 different ways. If we look at this graphically, as x gets closer to 1 from the right, y is getting closer to 4. And we can write this using limit notation as well. Since we're going from, I meant to go from the left first, but that's okay. Since we're going in from the right, our x values are approaching that from the right. We can see we're approaching 4. And if I was using limit notation, what I would say is the limit as x approaches 1 from the right of f of x, this is 4. So that little plus sign above the 1 is telling you from the right. And we can also look at from the left-hand side. So as x gets closer to 1 from the left, y is approaching, I'm going to say getting closer to 4 as well. And so what we say then is the limit as x goes to 1 from the left, and if we look at this graphically, we're starting at numbers that are smaller than 1. So we call it from the left. And we toss that little minus sign up there. Of f of x is equal to 4. And since both of these limits are going to 4, we can say that the limit as x approaches 1 from either side, from both sides, when we just put that 1 there, we're kind of assuming it's approaching the same number from both sides of f of x is equal to 4. So that's if you were to do this graphically. Again, sometimes graphically doesn't work. And we'll see an example like that today where using a graph just doesn't help us at all. We can't really tell what's going on. So we'll need to be able to do this algebraically. And doing this algebraically, we make a t-chart. If we start from the left, we start from numbers smaller than 1. So we might use 0.9. We then might want to get a little bit closer to 1. 0.99. And we might want to get a little bit closer to 1. So 0.999. So we're getting slowly closer and closer and closer to 1. If you plug those back into our function, we get 4.19, 4.02, 4.002. And you can see it's getting closer and closer to 4. If you don't see a pattern, and you just have 3 numbers, try 4 or maybe 5 numbers. If then you still don't see a pattern, your graph is probably oscillating or shooting off to infinity, or something weird is happening to it. So this is from the left. And it's getting closer to 4. And then we have our 1, and we know it's -2. But again, we don't really care about that. Just kind of scratch it off. And then if we want to look at it from the right-hand side, I might go to a number bigger, like 1.1. But then I want to move in a little bit closer. So I might go to 1.01. And maybe I get a little bit closer. 1.001. And then if I didn't see a pattern, then I could do 1.0001 and just keep adding in the zeros or adding on the 9s. Plug those in. This time we get 4, 4, and 4. And so from the right-hand side, we are approaching 4 as well. I'll put a little 4 down here. So that's kind of using algebra. And that we would use that if we didn't have the graph or the graph looked really bad and we just use the original function. But be careful on this one. For the 0.9, 0.999, 0.999, we would plug this into this top equation. And then this 0.001, 0.01.1, we would plug it into that bottom equation. So that's going back to kind of our piecewise functions. You guys remember those? Okay. If you get stuck on them, feel free to ask. Don't mind explaining. Okay, so any questions on this problem? You guys feel good about it? Okay. All right. So I'm going to let you guys try example 3. I'll walk around, answer questions. This one's a little bit trickier. You guys still working? All right, go ahead and talk about this problem. See if you approach it differently. If everyone in the group approach it the same way, how could you approach it differently? And talk.
So I did it since there's a jump here, I figured there's going to start exist, but exist coming from left to right.
You guys done talking? Okay. I let people talk as long as they want to talk. Normally. All right. So part A is pretty straightforward, hopefully. F at 2. What is F at 2? 3. Everyone agree? Okay. Not seeing very many head shakes, so I'm nervous. Yeah, we go to 2. Go up to our function. It's the bubble that's filled in, and that's at 3. So we get F at 2 is 3. Good job. All right, now B. B is a little tricky. So let's break this down a little bit further, and I'm going to use limit notation instead of words because words can be a lot of words. So we have the limit as x goes to 2, and let's look at this from the left-hand side. So if I'm coming in from the left-hand side, what is that function approaching? 3? Does everybody agree with that? Okay. So as my x's are approaching, let's use red so you guys can see that. So as my x's are approaching 2, this function is approaching 3. That's how we look at that limit. Again, tying this kind of together, we could have made a t-chart. And that's looking at numbers smaller than 2. So we could have looked at 1.9, 1.99, 1.999, and we get 2.81, 2.98, and 2.998. So that is coming in from the left. And we can see those numbers are getting closer and closer and closer to 3. So that's one way of looking at this. Let's come in from the other side. So we have a limit as x approaches 2, and we're going to look at it from the right-hand side of f of x. And what do you guys get as we're approaching it from the right-hand side? 6. Everybody else agree? Okay, so we get 6. Again, we can do this algebraically. I think I made my t-chart a little too small on the top, so we'll come from here. And if we look at 2.1, 2.01, 2.001, and we look at those numbers, we get 5.9, 5.99, 5.999. So when we're coming in from this way, from the right-hand side, our y values are getting closer and closer to 6. So now we have to ask ourselves, if our limit from the left-hand side is coming into 3, and our limit from the right-hand side is coming into 6, does the actual limit itself exist? Nope, it does not. Think about it as if we're flying an airplane in, we come in from one way, the landing strip's over here, and we come in from the other way, and our landing strip's broken over here. We're not going to be able to land our plane. It's broken. So they need to be the same so we have a full landing strip. Because when I look at those arrows underneath the algebraic ways, to me they look like little landing strips for airplanes. So what that tells me is that the limit as x approaches 2 of f of x does not exist. So that's kind of a key note here. And a fun test question. Was that enough of a hint? This would be a fun test question to put on your test. If the limit as x approaches a, I'm just going to put a down there, from the left-hand side of f of x does not equal the limit as x approaches a from the right-hand side. So those two limits are two different things. Then the limit as x just approaches a of our f of x does not exist. And the reason this makes a fun test question is because oftentimes when we look at these, if they're mismatched, most people's intuition tells them to go with what it equals to. And that's not what a limit is. A limit's what is it nearby? And if I go to 3, it's being split into 2 different pieces around it. So it just doesn't exist there. Okay, any questions about that? Everybody feels pretty good about this? Feels pretty good with limits? Okay. I'm gonna skip example 4. You You guys can do this at home, and if you have questions on it, feel free to bring it to class tomorrow. Yep, tomorrow, and we can go through it. But for right now, we're gonna skip this. And now we are gonna go to page 17, more limits of functions.